So welcome back to the session. The topic is friction. Okay, so let us see the diagram here. So there is an object of mass m which is placed on the horizontal surface, and initially the object is at rest state. Okay, now if I apply some external force along horizontal direction, so due to this external force, definitely the object moves along with the direction of the force, isn't it? Now look at in ground. So whenever an object is moving along horizontal direction, there must be a contact force which is developed in backward direction, and that contact force is called friction. See, in backward direction, so this is the friction which is developed whenever an object is moving forward. There must be another force which is developed in backward, that is called friction, and this friction always opposing the motion of the body, isn't it? So coming to the definition, so it's a very simple. The force acting between two surfaces that opposes the relative motion is called friction. Okay, so I wrote 3 bullet points here. The first point is it depends on the nature of the surface. That means, suppose if the horizontal surface is a very smooth surface, then whatever the friction developed here, this friction always very less. Suppose if the surface is rough surface like irregular surface, then the friction will be more. Okay, so that is the meaning of nature of the surface. And coming to the second bullet point, that is it is a contact force. Look at here, this is the black and this is the horizontal surface. There must be some contact was present, so that's why friction is a contact force. Okay, and look at one more point. So the force is acting here forward x-axis direction, and the friction will be acting backward direction, so both will be opposite to each other. So third point is force and friction opposite to each other. Okay, so coming to the diagram here, so this is the object of mass m which is placed on the surface. So definitely the total weight mg will be acting vertically downward direction, and this weight which is balanced by normal reaction, that is acting vertically upward direction, isn't it? So let us assume the mass of the object is 4 kg. Just assume mass of the object is 4 kg. Why I am telling this 4 kg? Because whatever the friction developed here, this friction always depends on the mass of the object also. Let us see, based on this point only, the total types of frictions depends. Okay, suppose if my applied force is 1 Newton, then this frictional force also developed same 1 Newton. See, force is acting forward direction and the friction will be backward direction. So 1 Newton is balanced by 1 Newton. So the object is at rest state only. Okay. Now my applied force increases to 2 Newtons. In that case, this friction force also developed same 2 Newtons. So in this case also, applied force is balanced by the friction force. So the object is again at rest state only. Now again my applied force I increase it to 3 Newtons. Then the frictional force also developed same 3 Newtons. Again both the forces are equal in magnitude but opposite in nature. So the object is at rest state. Now again I increase my applied force is 4 Newton. The frictional force also developed same 4 Newton. So still the object is at rest state. Now my applied force increases to 4.5 Newtons. 4.5 Newtons. But the frictional force is the same 4 Newton. I told you already, the friction depends on mass of the object. Okay. So whenever applied force reaches to 4 Newton, after that applied force only we can able to increase, but the friction force it doesn't change. So the friction force same 4 Newton. In this case, applied force is more as comparing to friction, so this body ready to slide along with the direction of the force. After that I increased my applied force 5 Newtons, but the frictional force is same 4 Newton. In this case my applied force is much greater than the friction, so automatically the object moves. Again I increased 6 Newtons, the frictional force is only 4 Newton, so here my applied force is much greater than the friction, so the body keep on moving along with the direction of the force. Okay, so based on this given force and friction, I'm going to classify the types of friction. Okay, so look at here, up to 4 Newton, up to 4 Newton, the force and friction both will be in same magnitude but opposite in nature. So this condition is called static condition. After that, my applied force is 4.5 Newton, but frictional force is only 4 Newton. So in this case, applied force is more, so the body is ready to slide. So that is called limiting friction. Sorry. After that, my applied force increases 5 Newton, 6 Newton like that, but friction force is only 4 Newton. So in this case, my applied force is much greater than the friction. The body continuously moves. So that is called kinetic friction. Okay. So coming to the types of friction. So there are 3 types: static, limiting and kinetic friction. So static means if applied force is equal to friction, the body is at rest state. So that is called static friction. Limiting friction means applied force is little greater than or equal to friction. In that case, the body ready to slide. So here frictional force is depends on the normal reaction. So I'm going to remove this proportionality constant. So that's why FL is equal to some constant mu s into N. Okay, where N is called mg. So N is balanced by mg. So FL is equal to mu s mg. Okay, so bring this mu s left side. Mu s is equal to FL by mg. Now coming to the kinetic friction. In this case, my applied force is much greater than the friction. So applied force is greater than the friction. In this case, body moves continuously. So here also Fk is directly proportional to N. Fk is equal to some constant mu k into mg. So bring this mu k left side. Mu k is equal to Fk by mg. Okay, so based on static, limiting and kinetic friction, so there is a graph between force versus friction. So along x-axis direction, I took applied force. Along y-axis direction, friction was present, and I chose the same values 1, 2, 3, 4, 5, 6 newtons applied force along x-axis, and similarly 1, 2, 3, 4, 5, 6 newtons along y-axis direction, that is called friction. Okay, so see, up to 4 newtons applied force is balanced by friction. So this condition is called static friction. After that, my applied force increases to 4.5 Newton. In that case, the body ready to slide. So this spike represents the limiting friction. Okay, after that, my applied force my applied force increases to 5 Newton, 6 Newtons like that, but the frictional force, it doesn't change, only 4 Newtons. So in that case, the body continuously moves. Okay, so I hope you understand. Thank you so much.